Hello everyone. So in this class we are going to discuss about losses in prestress. In previous class we have considered the losses in prestress due to friction. But in this class we are going to consider all the different losses that you can encounter in prestress in concrete. So let's go into in detail of this class. So we have considered one problem. The problem statement is like this. A pre-stressed concrete pile of 250 mm square contains 60 pre-tensioned wire, each of 2 mm diameter, uniformly distributed over the section. The wires are initially tensioned on the pre-stressing bed with a total force of 300 kN. Calculate the final stresses in concrete and the percentage loss of stress in steel after all losses. So it means you have a pile. The shape of the pile is not given. So suppose it's a square pile having 60 numbers of tendons placed uniformly. The dimension of the pile is 250 square. Okay, so that means its side is of 250 and the diameter of each wire is 2 and all the wires are stressed with a force of 300 kN. So these are the datas which are available: the Young's modulus of steel, Young's modulus of concrete, then creep, which is 330 into 10 to the power minus 6 per Newton per square of stress of concrete. Okay, so this is the strain per unit stress in concrete. So we have to find out what is the total creep, and from that creep we have to find out what is the loss in steel. Then total shrinkage, this is the value of shrinkage per unit length of the member. Relaxation of steel, 5% of the initial stress of the steel, and pre-stressing force 300 kN is given. So let's go into in depth of the solution. All the datas which are available to us are written here: ES, AC, P, B and D. These are dimensions. Numbers of tendon is 60. Diameter of which tendon is 2 Creep, which is per unit stress of concrete, is given. Then total shrinkage is given per unit length, and relaxation of steel. So first of all, let's find out what is the modular ratio. Modular ratio is given by ratio of the Young's modulus of elasticities of steel and concrete, which comes out to be 6.563. Now let's find out what are the initial stresses of concrete as well as steel. For concrete, P by BD, which is 4.8. Initial stress in steel, total stress by the total area of 60 tendons, which comes out to be 1.592 into 10 to the power 3 Newton per square. Now let's see what are the losses. So the first loss that we are going to calculate is the elastic deformation. This is the loss of steel due to elastic deformation of concrete. So for that, first of all, you need to find out what is the stress in concrete. That means suppose this is the section and here you have the tendon. Okay, these are tendons. Then if this is the strain diagram, then you need to find out what is the strain over here. Okay, how to find out the strain at this location? Either you can find out the stress and then you can convert the stress to strain, and then you can find out what is the stress in the steel, right? So here the stress distribution, is a the stress is direct stress also already there in the section, which is P by A, which is given by 4.8 or something, which is we have denoted as sigma concrete. Just now we have calculated sigma concrete, and if you multiply with M, that is modular ratio, then we will get what is the stress in steel, right? We can convert the stress in concrete to steel by multiplying the modular ratio, and this will give you the losses in steel because of the elastic deformation of concrete. Okay, so the equation for finding out the elastic deformation loss in steel is modular ratio into the stress in concrete at the location of the steel, okay, which comes out to be 31.5. Now the second one is the creep due to concrete. If you see, the creep value is given as the unit of as a unit of per Newton mm square. That means per unit stress, what is the creep strain that is given, right? Which is we have represented as delta creep. This is the creep per unit stress of concrete. So to find out the total creep, we have to multiply the total stress of concrete, right? So this is the creep per unit stress of concrete. So we multiply this one with the total stress in concrete, which will give you the total strain due to creep. Okay, this will give you total strain due to creep. So if you multiply this with Young's modulus of elasticity of steel, it will convert to stress due to creep, right? And which will be the loss in steel due to creep, and which is 30.24. Okay, then shrinkage of concrete. If you remember, the shrinkage of concrete is given in terms of length, right? So this is a total shrinkage. So shrinkage into the ES, Young's modulus of elasticity of steel, you just multiply both, you will get the shrinkage loss. Shrinkage strain into Young's modulus of elasticity of steel, will get the total loss due to shrinkage. Then relaxation of steel, that is given 5% of stress of initial stress of steel. Okay, so you just multiply 5% with the stress of steel, you will get 79.577. So this is the total loss due to relaxation of steel. So yes, now if you add all the stresses, we have not considered the stress due to friction because all the wires are straight. There is no parabolic shape, or there is the shape of the tendons. In this problem, the friction losses are not considered. Then the total loss becomes the losses due to elastic deformation, losses due to creep, losses due to shrinkage, and losses due to relaxation of steel. So if you add this, then it becomes 183.317 Newton per mm square. So this is the total loss in the steel. Now the effective pre-stress. Now if you find out what is the effective pre-stress in steel, then initial stress in steel minus the loss, it becomes 1.48, 1.408 into 10 to the power 3 Newton per mm square. And the final stress in concrete, so this is the effective stress in steel into the area of the steel, then it becomes the effective force in the steel by the area of the concrete. It will be P by A, which will give you the final stress in concrete, which becomes 4.249, and the percentage loss of stress in steel becomes loss by the stress in steel into 100, which becomes 11.518 percent. Okay, so this is how you can calculate. So I would suggest you to remember the equations basically. So this equation for elastic deformation, you have to multiply the modular ratio with the stress of concrete. For the creep, most of the time the creep values are given. You have to multiply the creep with the concrete stress, then you have to multiply with the Young's modulus of elasticity of steel. For shrinkage, strain due to shrinkage into elasticity of steel, and relaxation, you need to multiply the percentage, how much percentage is relaxed with the initial stress of steel. Okay, so with this I would like to conclude today's class.